Welcome back. So let's look at this example. An official wonders whether less than half the students in her state are prepared for college math. She obtains a random sample of 500 student records and finds that, based on ACT scores, 219 of them are prepared for college math. Does this represent significant evidence that less than half the students are prepared for college math? Use the alpha equals 0.05 level of significance. So we're being given an alpha, and I didn't mention that before, but we will always be given that. So the researcher who's investigating, who's actually doing this, needs to set that, but we'll always be given that. And again, remember, this is going to give you the probability of making a type 1 error. Okay, so what are our hypotheses? Well, she is wondering whether less than half of the students are prepared for college math. So the alternate hypothesis that she's testing is that the population proportion is less than 0.5. That means the null hypothesis is that the population proportion is actually equal to 0.5. Okay, so remember, the null hypothesis is always going to have an equals. So we're going to assume that in fact exactly half the students are ready for college math, and we're going to state our conclusion based on in terms of whether we can the evidence supports that or doesn't support that. Okay, what else do we need to know? Oh, p-hat, this point estimate. So she got a random sample of 500 students, so the sample size is 500. 219 of them, based on ACT scores, appear to be ready for college math. So that's a point estimate of 0.438. And what we want to know is what we're going to test is it likely that if the true population proportion is 0.5, is it likely that we'd have gotten a sample this size with that low of a proportion? Now, let's go ahead and verify that the requirements to perform the hypothesis test are satisfied. You don't have to do this unless you're asked to, but sometimes you're asked to. So let's go through that. The sample is random. So it needs to be a random sample. How do we know that? The problem said so. It said she obtains a random sample of 500 student records. We need to know that NP times 1 minus P is less than or equal to 10. So let's see, N is the sample size, that's 500. P is 0.5, that's the assumed population proportion. Well, P is the population proportion, which we are assuming to be 0.5, and 1 minus 0.5. Do that on a calculator, you get 125, which is certainly greater than 10. And then third, the sample needs to be less than 5% of the student population, or 5% of the population. Now she's wondering about students in her state. So the population is all the students in the state. She's only got a sample of 500 of them. It seems reasonable that that would be less than 5% of the student population in the state. And like I said before, we're just we don't really have enough information here. We're to draw that, to say this for sure, and we pretty much never will in this course. So we're just going to say it seems reasonable. Okay, it seems reasonable to think that's true. So the three requirements for p-hat being approximately normal are satisfied, which means we can go on and use this method where we're using the standard normal table to come up with probabilities for p-hat. Remember, if p-hat wasn't a normal distribution, then we wouldn't be able to use the standard normal to get probabilities for it. And maybe let me actually conclude that here. So So p hat is at least approximately normal. With mean, so we're going to need the mean and standard deviation to convert p, this nice normal p hat needs to be converted to the even nicer standard normal z. To do that, we'll need the mean and the standard deviation. Mean is always the population proportion, which we are assuming again to be 0.5, half, 50%. And the standard deviation, that's going to be square root of p times 1 minus p divided by the sample size. Okay, and that works out to be 0.022. Okay, so here comes the actual hypothesis test. So I need to know the probability that I would have gotten a p hat, a point estimate value that's less than or equal to 0.438. In other words, that's as bad as 0.38 or worse. We convert that to a z value, which we can do because we know this is normal. And from a practical standpoint, we can do it because we know what numbers to put in here, that the mean is 0.5 and the standard deviation is 0.022. Crunch the numbers and you'll see that we're checking on the probability of z being less than negative 2.77. Again, that's our test statistic, it's called. And what are we going to get? So I want to know, and by the way, this is a left-tailed test, isn't it? So I'm on the table. That's kind of handy because so I'm looking for probability of z being less than, this is our z distribution, less than 2.77. That's nice because that's what the table gives us, is stuff to the left. So let's see. Negative 2.77, negative 2.77, that looks like 0.0028. Okay, so in other words, what, 0.28%. Now that seems unlikely, but we're not just going to be going on our gut anymore as to whether this seems unlikely or not. We're going to use the given level of significance. So what we have to ask ourselves now is, and remember this is called the p-value, that probability. So what we have to ask ourselves now is this p-value, namely the probability that we would have gotten a point estimate that's as bad or worse than 0.438, is that less than the chosen level of significance alpha? If so, so again, remember, if so, we're going to reject the null hypothesis. If not, we do not reject the null hypothesis. So you're always making your decision. When you make the decision, regardless of how you state the conclusion, when you make the decision, what you're always deciding on is, do I need to reject the null hypothesis because the probability of getting what I got is so small? Or is the probability of getting what I got big enough that there's not enough evidence to reject H naught? So you're always making your decision in terms of rejecting or not rejecting the assumed truth of the null hypothesis? Well, let's see. We're going to say yes, because this p-value that we got is 0.0028. That is less than alpha. Alpha was chosen to be 0.05. So again, if your p-value, your probability is unlikely enough that it's less than alpha, you're going to reject H naught. That's what happened to us here. We got very small probability of, if the actual student population, if the actual student proportion is actually 0.5, it's very likely that unlikely that we would have gotten this answer, or it's very unlikely we would have gotten that answer. Okay, so we're going to reject. So reject H naught. And conclude. I guess I typed that out for us. So conclude, there is or is not sufficient evidence at the alpha equals, that was supposed to be 0.05, at the 0.05 level of significance to conclude that fewer than half the students in the state are prepared for college math. So remember, H naught was the statement. So H naught was the statement that the population proportion is equal to 0.5. H1 was the statement that the population proportion is less than 0.5. We've decided that we're going to reject H naught. That means our conclusion is that there's enough evidence to conclude that this is true. So there is sufficient evidence at this level of significance to conclude that H1 is true, that fewer than half of the students in the state are prepared for college math. Okay, so here's one for you to try. Doing basically the same thing. The drug Lipitor is meant to reduce cholesterol, and in clinical trials, 19 out of 863 patients taking Lipitor daily complained of flu-like symptoms, side effects. On the other hand, 1.9% of patients taking competing drugs report flu-like side effects. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect? Use the alpha equals 0.01 level of significance. Okay, I don't think I have anything else to say about this. I think you can follow through the example, follow through the steps in the example I just did, I hope. But anyway, give this a try, and we'll come back and go through it together in the next video.